uniqueness part of this ontological proof. I haven't looked at it yet. Might have to come back to it, but it's kind of interesting. And we already kind of looked at the uniqueness part when it's for the ultrafilters. So because for ultrafilters, we said that those principal ultrafilters are of this form, where everything contains this one subset, okay? And that one subset could only contain one element, okay? Because that one element, because of the property that everything is either, so, if everything has to contain one subset, then either every set has to either contain that subset or its complement contains that subset. And that's only true for one element subsets. Simply because if you had two elements, there would be sets which contain one of the two, but not the other one. And that set does not satisfy this property. So these would have to be one element subsets. So and then the principal ultrafilters exist, and they have basically a godlike element, and it's unique. Okay, but the notion but there might be more than one principal ultrafilter. Okay, so if so that once there's more than one notion of positive property, but once you've fixed that notion, the godlike element exists and is unique. Okay, and then I want to see what happens in the actual Gödel's the other version that's not involving sets but more just logic. Where is it? Does it have uniqueness? This is the proof of the existence. Here it is. There is exactly one godlike being. Extensional interpretation of Gödel's argument. The positive being positive implies there exists X for which the property is realized. Okay. So this would be saying every statement in our ultrafilter has a non-empty subset for which it's true on. Okay. Yeah, so the empty set is not in our ultrafilter. Okay, that's basically what that's saying. So if I were positive and had no elements, then the empty set would be positive. Since necessarily, and now we're working with sets again, this is not what I want to do here. Actually, I'd rather work with sets in the Wikipedia part. Working with sets here is unnatural because we never introduced them. So the empty set would be a positive element. And the negation. Yeah, I guess basically the argument is trying to say that if it was positive and nothing was true for it, then if it was positive and nothing was true for it, okay, then it should imply every other thing, okay, because um, you know, because the empty set is a subset of every subset. Okay, so if nothing was true for it, then every, basically every single set would be like the truth set of a positive property. So the filter would be trivial; it contained everything. Okay, so if that's the case, was there a contradiction? Oh, okay, there was an axiom. So it was like that something was positive or its negation was positive, right? So that means like basically if you took the biggest set, um yeah, the whole set for which this applies. This is I don't really like discussing sets in this context actually for some reason. Anyway, so you have the whole set and you have the empty set and they're complements of each other. So the properties for which those sets correspond to are negations of each other. Okay, and so only one of them can be positive. But okay, they can't both be positive. Right? Can they not both be positive? Yeah. Yeah, they can't both be positive. And this is saying that they both are positive. And the corollary is that there is exactly one God. So if there were two different x and y that satisfied being godlike, and if the single element set is not positive, it's not the set of a positive property, then we would get that the complement of it is positive. Okay, so yeah, so that's a contradiction because x had all the positive properties, okay, so it can't have the one of its complement. So therefore the negation of x, yeah, it's just spelling out the contradiction. Okay, so then x is the positive property, just the statement for which only x is true. I guess this is, yeah. And then obviously gy means that the set of y is a positive property, okay? And so being godlike means you have to have all the positive properties, so x has to be equal to y. Okay, this is actually exactly the same argument of the ultrafilters that we just went through before. So it's a bit of a shame because it wasn't even phrased in another way. It was actually just phrased in terms of the sets. Okay, and so this doesn't seem to be really part of the original argument or in the style of the original argument. Even it might just actually be um, sort of a translation of the ultrafilters proof. Okay, but there being something that satisfies the positive element is the fact that basically comes from the fact that um, something or its negation must be positive. Okay, and so I think the existence proof must use that a lot as well. You know, so yeah, this is not positive. This is positive. We got negation. Yeah, so um yeah, so I think it's very interesting to look at it from the point of ultrafilters. And it makes it very clear what's going on, especially. So so the question really comes down to finding a set which we can take to be sort of a set of beings, and then we can prove that there exists a godlike element in that set. But to do that, we have to define the notion of a positive property, or maybe the notion, another, or another way of saying that is choosing a principal ultrafilter on the power set of that set. Okay, and then once you've done that, there exists an element which is godlike and is unique. Okay. Okay, so that's kind of good, but the problem is obviously that the choice of positive property, the definition of positive, and the choice of ultrafilter is not necessarily unique. Okay, there's one different ultrafilter for every different element of the set. Okay, so I'm gonna leave it at that.